Okay, so the next thing we're going to do, you right done? All right, while you're writing, the next thing we're going to do is take a different shape that's not a hexagon and make sure you're able to find those angles that they would be requesting. Is anyone still writing? No? All right. So this time we're going to talk about a pentagon. How many sides does that have? 5 sides. Or triangles, if you're thinking in terms of triangles. So. Okay, so here's our pentagon. We're going to draw in we'll draw in 2 of the triangles. Draw the apothem in 1. We're going to call this one angle 1. This is going to be angle 2 and angle 3. So this is kind of a sample of one of the things you would be doing in the homework, okay, with just the angle measures. So, knowing that it's a pentagon, knowing there are 5 triangles that are congruent, how are you going to find your main central angle? So 360 divided by 5 makes each central angle 72 degrees. So that means angle 1 is 72 degrees. Now let's move on to angle 2. If a central angle is 72 degrees and we just put that apothem in, then how do we find angle 2? 72. Should be 72 divided by 2, or 36 degrees. So both of these are 36, right? On to angle 3. How are you going to find angle 3? Yep, because this is 90, that leaves 90 degrees for your 180. So these two should be complementary. So 90 minus 36 will give you angle 3, which is 54 degrees. So angle 3 is 54 degrees. And we found all of that just by knowing that it was a 5-sided figure, regular pentagon. All right, so this is where we get into the actual formula. I'm going to give you my version of the formula, and I'm going to show you how it applies to the book's version, the actual formula, so you know how to exchange a couple things, okay? We're going to go back to that pentagon or hexagon. And this is not just the formula for the hexagon, it is any regular polygon, from triangle on up, okay? I'm just going to demonstrate it with the hexagon. All right, so if we draw in that apothem, and the book is going to call this S, not 5, S because it is a side of our polygon. I don't like the S's because they look like 5s, but that's what you're going to see in the book, okay? There's our right angle. Okay, now ignoring everything else you see except for that triangle, it's just a triangle, right? Yes? If I can find the area of this triangle, since it's congruent to all the other triangles, if I multiply it by the number of triangles, I should have the entire area, right? Okay, that's my adaptation of the formula. So we're going to say, find the area of one triangle and multiply it by the number of triangles or sides, and you've got the complete area. Okay, so it doesn't matter to me, I mean, if you want to think of this in terms of a base and a height for your triangle, then you do 1/2 the base times the height times the number of sides, okay? So area is 1/2 base height, and there's no good way to represent that with S, because that's S we don't want to reuse, but we'll just say times number of triangles. Now, let me show you how the book does this. And you could very well see this on state testing if they gave you a formula sheet and you need to know, if you're going to use that formula, you have to understand its parts. Otherwise, if you can remember a triangle times the number of triangles, that's the easiest to remember, I think. But the book formula is 1/2 times the apothem times the perimeter of the figure. And they get the perimeter, remember we said the number of sides comes into play? Well, the base of the triangle times the number of them really is the perimeter, right? You guys see that? Yeah, I mean, that's the perimeter of your figure because all these bases are the same. So the book says it's 1/2 apothem times perimeter. The P stands for perimeter. People typically mess this up because they don't find the perimeter, they just use the side length. So you kind of have to commit to one or the other and stick with it. We're going to do a couple examples and then we'll pick some out from your homework also. Now, the easiest ones are where you don't have to find anything that's missing. Okay, and actually, I think on the example, the 12.3, like they don't have the radius drawn in. But that's the first thing I would suggest you do, is draw at least one triangle. Okay? So we've got the apothem and we've got a side length. Using my general formula, area is 1/2. What's the base of my triangle? 8. So 1/2 base height times the number of triangles. So the height would be the apothem, 12.3. And the number of triangles in a hexagon is 6. If you did the 8 times 6, that would be your perimeter, right?
Is that 12.3 or 1.3?
12.3. Now, if you're putting this all into your calculator, I do 0.5 for half. Just do 0.5 times 8 times 12.3 times 6. You've got your area. So this area is 295.2. We'll call this inches, so that would be in square inches. It's 12.3. That's 0.2. Yeah, 295.2. Now, if you do happen to have missing dimensions, that's where those angles come in. There are only a couple polygons that actually have nice central angles that give you a 60 or a 30 or a 45. That's why we aren't alternating a lot of the different polygons, because like a 7-sided figure, well, the pentagon, you saw the central angle was 72 and it made two 36-degree angles. Those are not special right triangles. Now you could use trig to find a missing apothem or side length, okay? But we're kind of sticking with the ones that give you special right triangles. So here there are 6 triangles. All they're going to give you in this one is a side length. In fact, that might not even be there. They might just tell you it's a hexagon with a side length of 10. So first thing I do is I draw my little triangle. If this gets too little for you, you can always go over here and just focus, make it bigger. Since the central angle is 60, right, for hexagon, then each of these, remember, were 30 for a hexagon. If my base is 10, then half of the base would be 5, yeah? We need the apothem. That's really what we're looking for. So across from 30 is x. The apothem would be across from 60, so that would be x radical 3. So what would my apothem be? Yeah, if x is 5, then 5 radical 3 should be my apothem. Once you have a side length in the apothem, you have everything you need to calculate the area. So area is 1/2 of the base of a triangle, that's 10, times the height of the triangle, which is the apothem, 5 radical 3, times the number of triangles, and there would be 6. Now this is a little bit different because it has that radical. You can't just punch everything into your calculator unless it says round to the nearest 10th. So we do everything but the radical. Half of 10 is 5. 5 times 5 is 25. And 25 times 6 is 150 times the radical 3. So this would be 150 radical 3. And we'll just say that's in meters, so that would be square meters.